1967 was a year with no fear of being bland. The Beatles gave us Sgt. Pepper's Lonely Hearts Club Band. It was the year that Elvis Presley in Priscilla found a bride. And the year Vanilla Ice was born and Che Guevara died. We saw the QE-2 being launched, Surveyor 3 land on the moon, and more. France's fourth Five Nations win the succinct Six-Day War. These things are all important, yet I must admit they bore me when compared to what this rap's about, so now I'll start the story. 1967 saw a girl fight through her PhD in radio astronomy at Cambridge University. Was born in Northern Ireland and determined to excel. Became a sage and superb scientist. Her name is Jocelyn Bell. She saw a signal come from space in waves of radio. As the signal kept repeating, Bell's intrigue began to grow. When she timed these perpetual pulses, Jocelyn's interest was multiplied more. The seconds between all the signals had stayed at specifically 1.34. Well, how could this be? It's not easy to see how a thing that must be astronomic could produce and preserve this odd sight we observe, such a signal that's so metronomic. This bizarre circumstance must mean there's a chance of an extraterrestrial sender. Outlandish maybe, but this theory must be a quite carefully considered contender. But Bell stayed reserved because the more they observed, the more sources were seen all around. The celestial sphere so was more and more clear a new object in space had been found. These objects became known as pulsars because they look like a pulsating star. And soon you will be a pulsar devotee because they're fascinating and bizarre.
So it turns out to be a new kind of star. Totally undreamt of, hugely exciting.
So specifically, what is a pulsar? Well, I don't want to cause you to cry, but so that a pulsar can start off its life, a big beautiful star has to die. When a star's run its course, the self-gravity force overwhelms and it goes supernova. Now the star is no more, and a super-dense core is all that lasts from the blast and left over. What remains weighs the same as 1.4 suns, or half of a million Earth masses. All that matter squashed down to the size of a town as a neutron star this core now classes. It's tricky to convey how much a sliver of this stuff can weigh, but if we brought a single spoonful here to test, what would it weigh? We would find that here on Earth, this neutron spoonful would be worth the weight of Matterhorn, Mont Blanc, or Everest. This immense density leads to strong gravity, near 1 trillion times stronger than ours. Such a stupendous force would suggest that, of course, just to stand up you'd need superpowers. Now, the fastest one we know about can rotate, so it's reckoned, more quickly than a kitchen blender, some 700 spins a second. This spinning core yields mighty magnetic fields. They're 1 trillion times that of our world. At poles north and south, particles are pulled out by the field and then into space hurled. As they accelerate, charges must radiate, make electromagnetic emissions. So thin beams flow forth from the magnetic north and the magnetic south pole positions. This shaft of radiation, quickly spinning, makes it seem like the neutron star is sending out a giant lighthouse beam. If this thin beam points at Earth, we see a pulse of radiation. And a space lighthouse light years away is the marvelous causation. When we see these objects pulsing, then we call it a pulsar. But it's really just an earthward-pointing normal neutron star.
The physics inside these pulsars or neutron stars is utterly amazing.
So you now know the basics of pulsars. They're the core of an exploded star. Near 3,000 are known at the time of this rap, but the Milky Way hides more by far. They're spread throughout the galaxy and universe, no doubt. We owe what we know to that first pulsar, though, and the pulses it kindly sent out. Though discovered by Jocelyn Bell, it was never named after no one. In fact, that neutron star is known as PSR B1919+21. So a long time ago in our galaxy, and reasonably far, far away, that first pulsar was beaming emission, as it did all day, every day. That beam streamed through space for some 1,000 years till to Cambridge it finally fell. Right on the nose of a new telescope and was caught by young Jocelyn Bell.